enterprise application value with Red Hat and IBM systems. So my name is Mike Potter. I'm a solutions architect from Tech Data. Also joining me on the call, we have Andrew Laidlaw and Adrian McGorry both from IBM. So today what we're going to focus on is a number of areas that we'd like to discuss around application value, Red Hat and IBM systems, and how that all starts to come together. So what we're going to discuss is the challenges that we believe organizations are facing today with application modernization, and how we look to address these challenges, and why the platform matters for both compute and storage. Then we will look at some real world examples to show you how and what we know and how it can be applied in the real world. So let's have a look what we're seeing. So it depends on which analyst firm you generally speak to and what terms you look to use, either application modernization, microservices, containers. But there's lots of stats available. But the drive towards modernization is certainly happening. So there's been a number of accelerators, the push towards cloud being the major one, and the effect that IT has on determining how successful you are as a business. And basically, if your business is underpinned by a modern and agile platform, it enables you to succeed as a company. But this journey can be very difficult. So let's look at how we can understand some of the considerations and what these challenges are. So some of the most common challenges for app modernization are cost, management, functionality, complexity, and storage. So the challenges within application modernization typically boil down to two things in reality, which is cost and complexity. So many companies consider moving an application from on-premise to the cloud with little or no thought to the ROI. So moving applications just to move for the sake of them is really not a solution. Also, applications that might benefit from merely from replatforming or re-architecting are so heavily coupled with their existing systems and infrastructure that the complexity of modernizing in the first place might actually outweigh the upside. So deciding where to start for a lot of organizations is really quite complex. So most organizations are dealing with a real complex landscape of multiple technologies, platforms, unsupported environments, legacy applications. On top of that, we have overlapping business process dependencies across applications. Integrations are just a couple of the reasons why organizations really don't know where to start with this. So let's address a couple of these items. So we have cost. So every organization pain point and project manager's nightmare is budget overrun. So a lot of us have inflexible, aging, and poorly integrated IT systems. And this can really hinder what the organization's ability to quickly innovate and deliver new products and services to the marketplace are. And add to this, we have actually an aging IT workforce, which creates concerns around looking to modernization and how do we do it. So we really have to start to understand what they've got, and then that starts to kind of depend on a lot of the areas around cost. And leading to management, we have deploying legacy applications and containers can certainly start to remove some of the barriers to the change. But then we have to look at the process should we start to decouple applications from old infrastructure and then use the same platform to host legacy applications in a new development? But is this the right thing to do, or is there a better way? And then if we look at functionality, so legacy applications are often deployed on infrastructure that is fixed and limited resources. Often the resource utilization is low, but yet when the demand increases, it's challenging to scale up without the long lead times, without the high costs. So while many legacy applications have had stable and predictable growth in the past, the new user-driven demand, certainly what we've seen in 2020 in a COVID-related world, we need to have those resources available really swiftly, and that application needs to scale up with whatever user demand we actually have. And then if we look at complexity, developers need tools for building the application, and they need to understand the dependencies within that. But some of the low-level tools do exist performing these tasks. a container platform could make this processing much easier. So building containers to run applications often requires languages, runtimes, frameworks, and the application servers to allow it actually to run. And then if we start to kind of focus on storage too. So data centers, as we know, have a lot of storage, and it's a real area of focus to what we're looking to do. So most organizers today, as we've seen, have multiple data centers with branch offices and some cloud-based data. And most organizations, in all cases, really want to place the data as close to the user or the applications as possible. So what we see is that the legacy solution is to create, for multi-workloads, is to implement separate storage for each workload. But then we're starting to do that for each application. It starts to simply become uncontrollable and unmanageable and impossible. So forcing the organizations to purchase separate storage systems for each workload is just unattainable. So, and the other method is to look to use, can we use scale out systems to address the performance capacity issue of storage? And you still end up with a similar scenario of silos. And in addition to that, you get expansion with just simply adding a node, which doesn't actually start to solve that, because the nodes usually have to be very similar to what we have before. And then we're trying to provide those different performance metrics within that can be quite challenging. So neither legacy storage solutions or scale out storage solutions can address the multi-location problem of your applications. So each require actual separate silo of storage per location, and again, each workload per each location. So how do we ensure storage can be accessed by our new containerized applications is something that we'll look to address. So what I'll do, I'll now hand you over to Andrew so we can look to discuss further of how we can address some of these challenges.
Thanks, Mike. So yes, as Mike was saying, with application modernization, building new applications that are cloud ready and developing and adding new functionality to your existing applications, one of the key trends we're seeing is containers and containerization, and using this new model to deploy smaller microservices and connect them together to deliver real value to end users and therefore to businesses. And that's where Red Hat OpenShift comes in as a container platform, and more importantly, as a container orchestration platform. And it's the orchestration piece that adds huge amounts of value here, because that's how you can make sure that all of your new containerized applications, your microservices, can interact with each other, can scale independently of each other, and can be deployed in manageable and flexible ways to meet the demand wherever that might be. And the Red Hat OpenShift container platform kind of has three key focus areas. One of them is automation and standardization. So simplifying the management processes, simplifying the management of the systems, of the workloads, and of the life cycle of applications that are being deployed. And that comes down to automated upgrades, automated scaling, all based on policies that a management or an administration team can set, knowing that they work for the business. The second area is developer productivity. So that's providing the tools, providing the capabilities to help the development teams develop and to focus on building their code and solving those business problems. So without thinking about the underlying infrastructure, without needing to know how their models and how their applications are deployed, but concentrating on what will actually bring value to the business. And then using all of those automated tasks to fit that in to the business processes, to speed through the test processes, and to make sure that those applications, those models can be deployed in the right places as quickly as possible. And then although it's based on the open source Kubernetes container platform, Red Hat OpenShift adds so much more on top of that. In the same way that Red Hat has done with Red Hat Enterprise Linux, it takes the Linux kernel and adds tools, adds capabilities, and focuses on security and enterprise readiness. That's the same with OpenShift. It extends Kubernetes. It adds security features, it adds management features, and it makes it as simple as possible for developers to develop and for administration teams to manage those systems. And if we look at the 5 considerations that Mike was talking about earlier, it addresses all of these in a variety of ways. So in terms of cost, we can use a consistent hardware platform for both the cloud native workloads, the new container-based workloads, and also existing workloads running in virtual machines. And these two can coexist, and they can interact through the same interfaces and using the same tooling. So it's reducing the cost. You don't need to invest in new infrastructure. You don't need to invest in new cloud services. You can really manage your costs. And on the management side, we can separate that development process from the operations, using automation, using standardization to simplify the process for both teams and to allow each to concentrate on their area of expertise. We can also increase functionality. So we can add new development tools, we can add new capabilities, we can even add new software elements alongside existing environments, giving a lot of flexibility in how our developers develop and how businesses can join their applications and join their data sets together. And all of this whilst reducing complexity. Because we've abstracted the infrastructure layer from the workloads, people don't need to understand every layer of the stack. And that speeds development cycles, that speeds integration, and it allows the right teams to concentrate on the right things. And most importantly, it gets new capabilities and new tools out to customers much more rapidly than ever done before. And of course, there's the storage layer. And with Red Hat OpenShift, we can actually bring persistent storage into the mix. So rather than having entirely ephemeral containers where all of the data needs to be managed separately, we can actually bring that persistence of storage and that data management within the container platform. And we can do that with container-ready storage options, connecting in existing storage, or with container-native options that allow developers to just pick and choose not the storage infrastructure that they want, but the features, the functionality, and the capabilities that they want from the storage that underpins the tools that they're developing. So why is Red Hat OpenShift the right foundation for hybrid cloud? It's a consistent developer experience. It runs anywhere in the same way with the same tools, and developers could just concentrate on their code and not on the infrastructure that it lies on. It's a consistent interface. So no matter where this is running, an OpenShift will run on premise, on Power Systems, on IBM Z. It will also run on the IBM Cloud and other public cloud services, or on other on-prem options. That interface is the same, and you can use that across multiple cloud environments to give you the same automated operations. The tooling, not only for the management, but also for the development, that is consistent across everything. And it gives you that kind of security and resilience that you come to expect from enterprise engagements, which Adrian can cover in a bit more detail with some examples.
That flexibility and consistency and abstraction are absolutely key tenets of OpenShift, but the role of infrastructure and platform does still play a role in terms of cluster strategy and cluster management. Red Hat OpenShift does give the flexibility to deploy to choose where to deploy workloads, but it balances the need to keep workloads close to the data on-prem while taking advantage of the agility and flexibility of public cloud. And Andrew's covered, in doing so, OpenShift is a key enabler for hybrid cloud. But it goes beyond that. OpenShift is optimized for IBM Power Systems to deliver superior cloud flexibility, lower TCO, and accelerated performance. And it does that through that acceleration and the ability to run more containers per core density, and in turn give greater efficiencies of your infrastructure investments. And as a result, cloud native applications run more efficiently with OpenShift on Power. Power also provides cloud consumption models to lower IT acquisition costs and delivers a by-the-minute pay-per-use consumption model to reduce IT acquisition costs. But it also brings AI acceleration into cloud native applications, and for deep learning models can deliver and train more models per hour than any other platform. So IBM and Red Hat combine the data crunching capabilities of Power servers with a streamlined platform to develop, deploy, and manage container applications, as we've covered. We believe that in choosing a clustered infrastructure, the ideal is to build a foundational capability for the platform to support a wide range of use cases with that agility and flexibility. And IBM Red Hat can deliver that by OpenShift on IBM Power. But it also delivers additional benefits inherited from the Power platform. Enhanced cluster reliability with the most reliable hardware platform. Enhance Red Hat Core OS with additional native security built into the hardware to provide an enterprise-grade container platform. And as container native applications become more mission critical, the reliability and security are key, as is accelerated performance, which we've covered. In fact, more and more we're seeing performance as a key use case for Power and OpenShift. So on the storage side, so as we've covered, originally containers were designed for stateless applications, but are increasingly being used for stateful applications. And as Andrew said, this is driving the requirement for container management platforms, including OpenShift, to provide a mechanism for persistent storage. But there have been other factors driving prioritization of storage for container strategy within our enterprise clients. We are seeing demand within cluster management to change how storage is provisioned from static, where storage administrators provide the capacity to cluster, to dynamic provisioning within the cluster. And when designing a cluster, an important decision is the type of storage, whether it's container native or container ready storage. Container native storage is software-defined storage that runs in a container within the OpenShift cluster. It virtualizes the underlying physical storage to create a storage pool that can be used to create new volumes and puts management of the storage system under the control of the OpenShift cluster. Container-ready storage is a storage device external to the cluster, such as a NAS, SAN, or object storage. And using an industry-standard CSI driver for the device, storage volumes are directly connected to the worker nodes by persistent volume claims. The management of the container-ready storage is outside the cluster, which means that experienced storage administrators are responsible for maintaining the integrity of the data, albeit possibly at a reduced level of responsiveness. But we're also seeing a demand for a widening range of application services running within containers, which require a range of protocol and access modes. And this offers flexibility and ensures that the container environment can support a wide range of use cases. And it is possible for container native and container ready storage to coexist within the same OpenShift cluster, and for multi-protocol to coexist within the same cluster. In fact, IBM believe that this hybrid architecture offers a degree of choice to ensure the agility of the OpenShift platform is maintained. To simplify the role of storage as part of our client's cluster strategy, IBM and Red Hat provide storage suite for Cloud Paks. All of the IBM and Red Hat storage solutions are available through a single software licensing model. The storage suite for Cloud Paks gives access to all the products and the flexibility to deploy whatever quantities needed, both on-prem and on public clouds. And all fully tested with Kubernetes, OpenShift, and certified with IBM Cloud Paks. At IBM, we believe in choosing a container storage solution that ideal is to build a foundational capability for the platform to support that wide spectrum of use cases with agility and flexibility. And IBM and Red Hat can deliver that by IBM Storage Suite for Cloud Paks. All of that ensures that you leverage your existing storage investments with certified software-defined software from both IBM and Red Hat. But if you layer in additional benefits of IBM storage, the combination delivers extra value to the cluster. For application acceleration and cluster performance, there's ultra low latency and low latency flash. To ensure your data is inheriting encryption at rest, and protection and recovery from malware attacks is all built into our systems. And finally, for application mobility, the capability to securely and fastly move and support data mobility within a cluster and across a cluster is one of the key tenets of IBM storage container strategy.
And this is being used with a number of our customer set to really get the benefits of not only what Red Hat OpenShift container platform offers, but the benefits brought by the underlying IBM infrastructure as well. So an Australian bank managed to completely transform its payment processing application using a container native development process, but did it all on the Power systems that were already running its core banking application. So it gave easy access to the data, but in a secure and resilient fashion, but then opened up that data again securely to be available through public cloud interfaces to allow them to provide new applications and new capabilities, making use of the core data and the core application that still sat at the heart of their business. And in fact, they were able to develop and deploy an application to help customers deal with the COVID-19 pandemic in under 2 weeks, using the development tools and the capabilities of the OpenShift container platform on Power systems. And then in the US state of Massachusetts, there's the Massachusetts Open Cloud, which is a consortium of research organizations working together to develop new capabilities, particularly around AI, on Red Hat OpenShift, on Power systems, using GPU acceleration to really boost the development of their machine learning and deep learning algorithms, and providing access to researchers in a flexible and scalable way to ensure that they could get their results much faster than they could previously. More importantly, this allows them to deploy all of those models and all of that intelligence they've created in a rapid but flexible way, thereby deploying this intelligence to where it's needed. And then close to home, Porsche Informatica, they have modernized their infrastructure using Red Hat OpenShift container platform and IBM Cloud Object Storage. That means that they can connect the same storage environment across 4 continents and the 30 countries that they work with lots of extra development work happening in Germany and across the globe. And it gives them not only the flexibility to share data and make use of this in new ways and in new locations, but it also gives them the extra security and governance that they need to manage the data that they're working with access controls and with the security and immutable storage available to them so that they can keep track of everything that's being done with their data, no matter how many new capabilities they're adding into their vehicles. And then the final example, another US state agency, they've actually taken all of this technology as one. They were already existing users of IBM Power Systems and IBM Storage, and they are still capable of running their existing AIX and IBM I applications, their core databases, and That's all running on Power VM in LPARs and providing the same value that it always was. But alongside that, they brought in OpenShift as a new development platform, which allows them to very rapidly create new tools, create new experiences. And they've even brought in some of the IBM Cloud Packs to improve the speed of delivery and the flexibility of delivery in this new containerized cloud native world. But they also link that to the IBM public cloud, where they are able to consume more IBM I and AIX resources. So more virtual machines as test and development environments, along with tying in that containerized workload. So extending their OpenShift environment across multiple clouds, all managed from the same place. And this also allows them to tie into other IBM services. So some of the Watson services, things like Watson Assistant in the IBM cloud, can be tied really closely into the development work they're doing, not only in OpenShift in the public cloud, but also OpenShift in their private cloud, sat on Power Systems on premise, tightly coupled with their core data.
Thank you, Andrew, and thank you, Adrian, for your input today. That was fantastic. So taking away from what we've seen and discussed today, so there's lots of complexities of what we've seen around application modernization and how we get there. And to say we highlighted a couple of areas of cost, management, functionality, complexity, and storage. And a lot of customers kind of have to decide where they want to start. And quite often we see a lot of our customers, certainly within the infrastructure space, already have something existing. And we're looking to build on top of that. And that, for me, is actually one of the good places to begin as a customer, and seeing how we can actually look to modernize that estate. That last example talked through greatly by Andrew, which for me a really marvelous example of how we can look to modernize an existing client's estate and to bring in different functionality and capabilities to get them to the cloud model of capability that they're aiming for. So it's really key to understand how we can do that and how we can start to build on top of that. But for me, it's all about having that capable and flexible platform underneath, and being able to add on those abilities such as OpenShift, such as Cloud Pak, such as Watson, bringing in all the AI ability around that too, and then being able to have that spanning out into a multiple cloud solution, either using could be a public cloud, it could be using multiple sites, it could be on-prem. It's really quite flexible for a lot of customers. So we can see that at the core of this is OpenShift, and that is starting to really focus our minds of how we can look to modernize applications. And we certainly need to really understand the power of OpenShift and how that can enable us to get to that next level. So certainly with the power systems, we see it as very much so a leading platform because of the ability of that actual CPU that we have. We're actually be able to consolidate more workloads onto single systems, and that's what we all want to do. And then integrate with those systems of record that were really the crown jewels for us as customers. So it's all about, say, looking at what you have and then maximizing that flexibility and creating agility, and then adding those modern features and functions that we all want to get to. So in my final slide, I kind of drew up a word cloud, which for me is always a great way to understand some of the language and the discussion points that we're having. So you can see here we have discussion. The main focus is all around the applications and how we do that and how we look to modernize that. And the answer is to look to containers. But then we also have to consider the legacy. We have to consider storage, the compute, which is power. But then we have to consider what's in the organizations and the challenges around that. And it's a really quite a complex area to deliver. But because of the different areas that IBM solutions that address, we can really look to do that. So if you'd like to, if you have any more questions, or if you have any more, if you'd like any more information, please feel free to reach out and contact myself or a member of the IBM team, and we'll see how we can address your solution for the future. Thank you.